All right, welcome. So today I'm going to be showing you guys how to use Git Bisect to find a breaking change in the Git history of a repository. I've taught this tutorial a number of times, mostly in a corporate context, and I can't share those videos that I recorded for that corporate context because of NDA reasons and me not being able to show actual proprietary code for many of those companies. But fortunately, I am working on a project that my company owns, and I've got no problem with you guys seeing what's under the hood in terms of our code. And so, yeah, we're going to take a look at this through the lens of a real example. Um, Earlier today, I noticed that we had a pipeline for our Storybook app failing. Now, it sounds bad, and it is, but it wasn't the end of the world. We hadn't noticed this pipeline failing because for about 2 weeks, our QA lead had been focused on testing against other environments as we ready ourselves for our next release. And so, still, we got to fix the pipeline. And so, this is a really good use case for using Git Bisect because the last time we built this app, this Storybook app successfully was about 2 weeks ago. And we're just under a handful of engineers, pushing numerous commits a day for the last couple weeks. And so I haven't done the math, but we've got somewhere between, 80 and 100 commits probably, maybe more, right? In terms of today versus the last time this Storybook app built. And so it's a really good use case for Git Bisect. Let's talk about why. So Git Bisect uses a famous algorithm in software development called binary search, right? And binary search is brilliant because it takes advantage of a key property to lists. Um, that property is order, right? If you have an ordered list, binary search allows you to traverse and find a single index in that list really quickly if you have some kind of predicate or condition around the ordering that you're looking to check. This will make much more sense when I show this in a Git history context. So I'm looking this way because this is where my monitor is. So let's see. Let's talk about it in terms of Git history. So imagine this string of zeros is our Git history, right? And each zero represents a commit, right? And so, fortunately for us, in the context of the problem that I happened upon earlier today, we can make a really important assumption. Um, Basically, we can assume that at some point we introduced a breaking change on Storybook. And let's mark that as this V, right? This V is pointing down to the commit where we introduced this, right? So, right. So it was here that we broke our Storybook pipeline. So here's the key assumption that we can make that allows us to leverage Git Bisect effectively to find this broken commit, right? So we can assume that everything to the left preceding that first broken commit, that Storybook app built fine, right? That it successfully builds. And then from that commit afterward, all the way up to today, right? It doesn't have to be to the head or to the most recent commit. It can be to, a week ago, whatever it is, right? Git Bisect allows you to decide exactly what the range of commits that you want to look at is. But back to my point, everything to the right of that broken commit is broken, right? And so binary search uses pointers to traverse ordered lists really quickly. And here's how it works. In binary search, you have a left pointer and then you have a right pointer. And I'm going to try and draw this live quickly. Wow, that was pretty cool. Okay. Um, Great. And so basically you find a left pointer and you pick a spot on that ordered list that represents, in Git history's context or Git bisect's context, this will represent the typically the last known good commit, right? So we're saying, 2 weeks ago, the last the last successful build is the last known good commit, right? And then you take a right pointer and you assign that to the first known bad commit. And in our context, I'm going to be lazy and just say that is the last commit on our main branch at the moment, right? And what binary search allows us to do, and this is what's happening under the hood in Git Bisect, is it's going to split the difference, right? And it's going to take advantage of the fact that wherever the broken change is, everything to the left is building correctly. Everything to the right is not, right? And we're going to go and we're going to split the difference. We're going to test and see if the commit that sits in between these two pointers either builds successfully or not. If it builds successfully, what we're going to be able to do is move this left pointer, right? And then we can split the new difference, right? And now we've discarded, you know, half of our full Git history, right? And so that's binary search for you, right? You have this range of indexes that you're looking at within an ordered list, and you cut it in. You take a measurement at the halfway point, and then you can cut that in half, right? Once you understand whether your condition was, true or false or whatever that predicate is. And then you've got a subset to look at where you do the exact same thing with half the number of indexes as you had to start with, right? And you keep following that until you narrow down the commit, right? And so at some point, we're going to arrive, here, right? And just to be clear, I don't expect it to be anytime soon, right? If this is the head of Maine, I'm pretty confident we're going to find, you know, somewhere a week and a half ago, those left and right pointers will coincide on the commit that ended up breaking things, right? And so let's see this in action. And for Git bisect purposes, let's replace left with the last good commit and the right pointer with first bad commit, right? And we will say that the difference roughly is going to be somewhere around here. Now, this is just a visual. This doesn't actually represent what we're going to find here. Let me grab the commit, the last good commit that I'm aware of for this change. All right, I've got the last known good commit from the last successful build in our storybook pipeline. Let's get started with Git Bisect. So in order to start bisecting, we type in Git Bisect start. Now, just a note, kudos, hats off to the core team over at Git. Whoever came up with this API, really nice job. Super semantic. I enjoy it. So nice work. Okay, so we're in bisecting mode. You can see that our local Git knows that we're bisecting, and it tells us it's waiting for good and bad commits. What it's asking for is the left and right pointers in our Git history to start with, right? Leftmost being our good commit, our last known good commit, and rightmost being our first known bad commit, right? As I said before, we're going to be lazy. We're just going to make this the latest commit on our main branch, right? Which is what we're on, which is head. So let's go ahead and tell it our first bad or our last known, sorry, our first known bad commit. And so we can do this. It's the same as not providing head. If you don't provide an argument to good or bad as a command, it's just going to take the current head that you're on. And so I'm going to just do it this way. So we've just told it, we're here, bad. Now we have to give it a good commit, right? It needs to know what is the leftmost pointer location in Git history. And so we can do that. There we go. And actually, it's going to autocomplete. And indeed, that is the correct commit SHA. I'm just gonna use this. I did this earlier today, which is why I still remember this. So that's a good one. Cool. And so now what it's done is it's established this pointer. It's established this pointer with the inputs we just gave it, and it checked us out somewhere in the middle And I think we're going to run out of space here. So what I'm going to do is I'm going to modify this. Bear with me. Let's make this a little bigger. All right. I just want this to make sense. And I think it helps to have this visual guide. So, all right. The visual is updated. So we are now here, right? And all we have to do is run a build. And look at that. There's our error, right? And so what we're trying to figure out is the current commit we're on a good commit in that it builds Storybook successfully, or is it a bad commit, right? Which it is a bad commit. You can see with the errors that we just saw logged out. Okay, and so all we have to do here is tell it that this is bad, right? Like I said, implicitly, this just grabs this, right? So git bisect bad. So what that does is it moves our bad pointer. Okay, that was not what I wanted to do. This becomes our bad pointer, and now it's going to split the difference somewhere here, right? And we can do the same thing. Run our build, and it's running super fast because of our cache at the moment, but does not negate the fact that it is erroring out. And so this is also a bad commit, right? And now we are checked out somewhere here. Run this again. Once again, errors. So we can move our pointers, right? Now this is anecdotal. This is not actually our full commit history. And at some point, I'm probably going to run out of space here, which is why I widened this in the first place. But you get the picture. And so um, let's see. This is bad, and so we got to tell it it's bad. Okay, now we're somewhere in the middle again between the leftmost good and the rightmost bad commit pointers, and we'll run this again. Once again, another error. I'm going to stop updating the visual because we've kind of run out of room here, right? I will do this. At a certain point, we will find ourselves with the pointer right between the good and the bad, right? And you can see we're kind of like making our way toward that end. And so let's see. That's a bad commit. We have 3 steps left. Let's run this. Also bad, right? Git bisect bad. And look at how fast we can move, huh? Pretty cool. This is a little different. Okay. So confirmation, some things are changing as we get a little closer to this side of our Git commit history. And so this one was still bad though. So let's tell it it was bad. And we have one more step, right? Now we're right at this point where we're going to find our singularity. It's going to zone in on the broken commit. So this one was a good one. How about that? And so we tell it this was good. Now check this out. It figured out this is the commit that we introduced the breaking change, right? And we can go and look at the diff here. Let's actually take a look. Git log. So let's check this one out. Where are you? Let's check this one out. Okay, and you'll see that, like I said, we're in this kind of a state here. Our last known good commit is the one that's immediately behind this, right? And so we can actually do a comparison um, in terms of the diff for these files, right? And so what we can do here is I've got my handy dandy little Git lens, and we can take a look and see what exactly was changed. Now this is comparing them in the wrong direction. So let's reopen this. There we go. And so in terms of figuring out where the breaking change came into play, we know it happened in this commit. So some of this diff needs to explain why our storybook is no longer building properly. And I can tell you there are a few things that are suspect, right? We've got a package JSON change. We've got a project JSON, which is for NX. Looks like we added a build command, which, if I'm looking at this and I'm not an engineer that's worked on this before, but I need to troubleshoot it, maybe this is getting called in the pipeline somewhere at this point. I don't know. But at this point, if you're following, the continued debugging flow here, you would start to look at and then maybe even start to modify and change some of these things and see if you can get a successful build, with no other regressions, right? And kind of zero in on exactly what it was that caused the breaking change. Now, it just so happens that I already know what caused the breaking change, and that was here. Uh, this is a declaration plugin for TypeScript within Vite, and we introduced some funkiness here. Um, Quite honestly, this might have been AI slop that just slipped through the cracks. Normally, we're really good about reviewing all of this. I think we probably had all local builds succeeding, which is why this didn't get picked up, and this slipped through. But I'm going to go ahead and switch over to main, and I'm going to apply. Let's get out of Git Bisect first, and I'm going to apply. Let's just make sure that I've got a handle on my stash. Yep. So here's the fix. Um, it was to revert just this little bit, right? And now, just to prove that this is fixed, we'll run this. We should see it succeed. All right. This is the moment of truth, right? This is where that plugin is coming into play, and it built properly. And so there you have it. Git Bisect to the rescue. Hope it made sense. And thanks for watching.